Is NASA now fighting a Trojan horse? Right now, moving at 245,000 kilometers per hour through the inner solar system, an object from another star system is doing something objects from other star systems should not do. It arrived from interstellar space with a trajectory that placed it within 5 degrees of the ecliptic plane, the disk containing all the planets orbiting our Sunday. The statistical likelihood of that happening by random chance? 0.2%. And on October 29, 2025, at its closest approach to the Sun, it will be positioned exactly where the laws of orbital mechanics would allow for maximum efficiency trajectory changes during an 8-day window when Earth-based telescopes cannot observe it because it will be hidden directly behind the Sunday. The object's designation is 3I Atlas. The International Asteroid Warning Network has initiated a coordinated global monitoring campaign. And some researchers are now asking whether we're watching the opening moves of a cosmic chess game we didn't know we were playing. Let that sink in. This is not speculation drawn from grainy photographs or misinterpreted radio signals. This is data collected by the Asteroid Terrestrial Impact Last Alert System in Rio Hurtado, Chile, confirmed by the Minor Planet Center, verified by NASA's Hubble Space Telescope, analyzed by the James Webb Space Telescope, and tracked by more than 15 spacecraft and ground-based observatories across multiple continents. The object was discovered on July 1, 2025, when Atlas detected what appeared to be a faint 20th magnitude point of light at 4.5 astronomical units from the Sun, just inside Jupiter's orbit. Within 24 hours, preliminary orbital calculations revealed something that made astronomers worldwide stop what they were doing. The trajectory was hyperbolic, an eccentricity of approximately 1.000016. For context, anything with an eccentricity greater than 1.0 is not gravitationally bound to the Sunday. It came from somewhere else. It's only passing through. And according to backward trajectory modeling, it originated from a region of space within 9 degrees of the direction from which the WOW signal was detected on August 15, 1977. Think of interstellar objects like messages in bottles. Our galaxy contains hundreds of billions of star systems, each potentially ejecting small bodies during planetary formation. These objects drift through interstellar space for millions or billions of years, following paths determined entirely by the gravitational configuration of their birth systems and subsequent gravitational interactions. When one enters our solar system, it's like finding a fossil from another world, a sample of chemistry and physics from a place we cannot visit. The first confirmed interstellar visitor, 1I Oumuamua, arrived in October 2017. It exhibited bizarre acceleration not consistent with gravitational forces alone, rotated on multiple axes, showed extreme elongation with an aspect ratio of at least 10:1, and produced no visible coma despite apparent outgassing. The second, 2I Borisov, discovered in August 2019, behaved like a conventional comet, complete with coma and tail, providing a reassuring data point that interstellar objects can be mundane. Then came 3I Atlas, and 3I Atlas does not fit either template. NASA's official stance is clear and measured. Tom Statler, NASA's lead scientist for solar system small bodies, stated that the object looks like a comet and does comet things. The European Space Agency confirms it poses no threat to Earth, with a minimum approach distance of 1.8 astronomical units, approximately 270 million kilometers, more than twice the Earth-Sun distance. Spectroscopic observations from the James Webb Space Telescope on August 6, 2025, detected carbon dioxide, water, carbon monoxide, carbonyl sulfide, and water ice in the coma. The Hubble Space Telescope captured detailed imagery on July 21st, showing a teardrop-shaped cocoon of dust, consistent with cometary sublimation. Ground-based observations from Gemini South and NASA's Infrared Telescope facility detected water ice on July 5th and 14th. The Swift Observatory confirmed water vapor and hydroxide ions on July 30th and August 1st. By every standard metric, this is a comet undergoing normal outgassing as solar radiation heats its surface. But here is where the skeptical mind must engage. Science does not progress by accepting surface explanations when underlying data patterns demand deeper scrutiny. Consider the analogy of examining a letter. The paper, ink, and language might all be conventional, but if that letter arrived via a delivery route that statistically should not exist, posted from an address that doesn't correspond to any known location, and timed to arrive precisely during a window when you couldn't observe the messenger, you would ask questions. You would ask those questions even if the letter's content appeared mundane. The mechanism of delivery matters as much as the message. 3I. Atlas exhibits 8 documented anomalies. Each individual anomaly is defensible as improbable, but not impossible. Collectively, they form what researchers are calling an improbability stack. Anomaly 1. Ecliptic alignment. The trajectory of 3I Atlas lies within 5 degrees of the ecliptic plane. Objects arriving from random directions in three-dimensional interstellar space should be uniformly distributed across the celestial sphere. The probability of alignment this close to the ecliptic is approximately 0.2%. Not impossible, but requiring explanation. Anomaly 2. The sunward jet. Hubble observations revealed a prominent jet structure pointing toward the Sunday jets on comets typically point away from the sun due to the geometry of sublimation and radiation pressure. A sunward jet suggests either unusual rotation-coupled venting or surface features not yet observed in natural comets. Optical analysis shows this is not a projection effect. The structure is real. Anomaly 3. Scale. 3I. Atlas has a minimum nucleus diameter estimated between 1.4 kilometers and 5.6 kilometers based on August 20th Hubble photometry. That places it orders of magnitude larger than Oumuamua, which measured approximately 400 meters, and substantially larger than 2I, Borisov. Its estimated mass is approximately 10 to the 15th kilograms. For an interstellar object ejected during planetary formation, this size is unusual but not unprecedented. Larger bodies require more energetic ejection mechanisms, typically close gravitational encounters with gas giants or stellar companions. Anomaly 4. The planetary flyby corridor. The trajectory of 3I Atlas brings it within tens of millions of kilometers of Mars on October 3, 2025, and will bring it within 54 million kilometers of Jupiter on March 16, 2026. Statistical modeling suggests the combined probability of such close planetary approaches for a randomly oriented hyperbolic trajectory is approximately 0.005%. This does not prove intentionality, but it does place the trajectory in a category that warrants closer examination. Anomaly 5. Nickel-enriched coma. Spectroscopic observations from the Very Large Telescope in Chile between July 14th and August 20th detected glowing nickel vapor in the coma at heliocentric distances of 3.78 to 3.19 astronomical units. Nickel emission from comets typically requires temperatures in excess of 1000 degrees Celsius, achieved only at perihelion distances well inside Mercury's orbit. The detection of nickel vapor this far from the Sun is extraordinary. The nickel to cyanogen ratio in 3I Atlas is orders of magnitude higher than any previously observed comet. This could indicate an unusual composition, possibly a metal-rich protoplanetary environment of origin, or it could indicate internal processes not yet understood. Anomaly 6, low water content. Standard comets are approximately 80% water ice by mass. Early observations suggested 3I Atlas has water content closer to 4%. This does not make it artificial, but it does make it compositionally anomalous. Low water content could result from formation in the inner regions of a distant protoplanetary disk beyond the frost line, but in a volatile, poor environment, or from eons of cosmic radiation exposure stripping surface volatiles. Both explanations are plausible. Both require the object to have had a very specific formation history. Anomaly 7. Extreme negative polarization. Polarimetric observations revealed that light reflected from 3I Atlas shows extreme negative polarization, a property not observed in any known solar system, comet, or asteroid, including 2I Borisov. Polarization provides information about surface texture and composition at microscopic scales. Negative polarization of this magnitude suggests surface properties fundamentally different from any material sampled in our solar system. Again, not impossible, but unexpected. Anomaly 8. Arrival direction. The backward integrated trajectory of 3I Atlas, accounting for galactic rotation and stellar proper motions over the past several million years, places its origin within 9 degrees of the sky position from which the WOW signal was detected at the Big Ear Radio Observatory on August 15, 1977. The WOW signal was a 72-second narrowband radio emission at 1420 MHz, consistent with an artificial transmission, never repeated, never explained. The alignment has a likelihood of approximately 0.6%. This could be coincidence. The human mind is wired to detect patterns, and sometimes patterns are noise. But it merits documentation. Here is the terrifying part. On October 21st, 2025, 3I Atlas reached solar conjunction. It is now positioned directly on the opposite side of the Sun as viewed from Earth. For approximately 3 weeks, from mid-October through early November, ground-based optical telescopes cannot observe it. The object is within 10 degrees of solar elongation, below the rejection angle of most coronagraphs, and overwhelmed by scattered light. During this blackout window, on October 29th, 3I Atlas will pass through perihelion at a heliocentric distance of 203 million kilometers, 1.356 astronomical units, just inside Mars's orbit. This is the point of maximum velocity. This is also the point of maximum solar illumination. At perihelion, the Sun will deliver more than 33 gigawatts of power to its surface, assuming the 5-kilometer minimum diameter. For reference, that is 1/3 the total nuclear power generation capacity of the United States. And this is the point where orbital mechanics becomes either fascinating or deeply unsettling, depending on your tolerance for ambiguity. There is a concept in astrodynamics called the Oberth effect. When a spacecraft executes a propulsive burn at the point of highest velocity during a gravitational assist, the kinetic energy gain is maximized. The optimal time to alter a trajectory, to change course, to deploy secondary payloads, to maximize delta V for a given fuel expenditure is at perihelion. If you were designing a mission to enter a solar system, conduct reconnaissance of multiple planets, and position assets for further operations, you would do it this way. You would arrive on a hyperbolic trajectory to minimize time in the system. You would align with the ecliptic to simplify navigation. You would schedule perihelion during a solar conjunction to avoid observation during critical maneuvers. And you would size your primary vehicle to carry enough mass for subsidiary operations. That is the uncomfortable implication sitting unspoken in multiple research papers published between September and October 2025. Let us be absolutely clear. The baseline hypothesis remains that 3I, Atlas, is a natural comet of interstellar origin with an unusual but not impossible composition and trajectory. The majority of the scientific community supports this interpretation. The chemistry fits, the outgassing fits, the thermal behavior fits, the morphology fits. Everything about 3I Atlas is consistent with a comet, albeit a statistically unusual one. But statistical outliers exist. They must exist. We have observed exactly 3 interstellar objects. Our sample size is ludicrously small. Drawing conclusions about the population distribution of interstellar objects based on 3 examples is like characterizing human diversity based on 3 individuals. It cannot be done responsibly. And yet, a group of researchers, most prominently associated with the Galileo project and affiliated with Harvard University, has proposed that the cumulative improbability of the 8 documented anomalies warrants systematic investigation of a low probability but high consequence hypothesis. That hypothesis is that 3I Atlas may be a probe of artificial origin, not alien spacecraft with warp drives and energy shields, but something more prosaic and more chilling. A reconnaissance platform, an automated survey mission dispatched thousands or millions of years ago, following pre-programmed instructions designed to catalog stellar systems, assess planetary environments, and possibly transmit findings back to whoever built it. Or not transmit. We don't know. We can't know without closer observation. The Galileo project submitted a white paper to the United Nations on September 30th, 2025, advocating for coordinated global scientific research to maximize observational coverage. Congresswoman Anna Paulina Luna sent a letter to NASA Interim Administrator Sean Duffy on July 31st, 2025, recommending evaluation of rapid response intercept capabilities. The International Asteroid Warning Network announced on October 21st a comet astrometry campaign running from November 27th, 2025 through January 27th, 2026, specifically targeting 3I Atlas to improve trajectory precision. These are not fringe initiatives. These are institutional responses to an object that refuses to fit comfortably into existing categories. Now let's talk scenarios. There are 3 broad interpretive frameworks, and it's critical to understand that choosing between them depends as much on philosophy of inquiry as on data. Scenario 1, benign reconnaissance. If 3I Atlas is artificial, it may be a purely observational platform, no different in intent than our Voyager probes or New Horizons spacecraft. We sent hardware to the outer solar system and beyond, carrying information about humanity, not because we expected anyone to find it, but because the act of sending represents an imperative to explore and document. If another civilization did the same, launching probes into the galaxy on ballistic trajectories, some would inevitably pass through our system. Such a probe would have no hostile intent. It would be a time capsule, a message, an outstretched hand across the void. The challenge is that we have no framework for communication. If it's transmitting, we might not recognize the signal. If it's receiving, it has no reason to respond. From this perspective, 3I, Atlas, would be the most profound discovery in human history and also the most frustrating. A one-way conversation with an artifact designed for recipients who may no longer exist. Scenario 2, active analysis. This is the hypothesis that makes policymakers uncomfortable. If 3I Atlas is artificial and operational, its trajectory suggests intentional survey behavior. Close approaches to Mars and Jupiter are not militarily significant, but scientifically invaluable. Mars provides data on planetary atmospheres, surface chemistry, and potential biosignatures. Jupiter provides data on gas giant magnetospheres, radiation environments, and moon systems. A probe designed to assess stellar systems would prioritize these targets. The timing of perihelion during solar conjunction could be coincidental or could reflect operational security, an attempt to minimize the risk of detection during the most energy-intensive phase of the mission. If mini-probes or subcomponents were deployed at perihelion, tidal forces from the Sun would gradually separate their trajectories from the primary object over subsequent months, making detection exponentially more difficult. By the time 3I Atlas reappears from behind the Sun in early December, any secondary objects would have dispersed across millions of kilometers of space. This scenario does not require malice. It requires only function. But function without communication feels like surveillance. Scenario 3, diagnostic or test platform. There is a third possibility that researchers mention only in private conversations or buried in technical appendices. If you wanted to test whether a stellar system contained intelligent life capable of spaceflight and observation, you would send something anomalous, not overtly artificial, but statistically improbable. Something that would provoke investigation by any civilization with basic astronomy. If that civilization responded by launching intercept missions, altering satellite orbits, increasing telescope time allocation, or broadcasting messages, you would have your answer. You would have characterized their detection capabilities, response time, coordination, capacity, and technological maturity. 3I, Atlas would serve as a probe in two senses. It would probe the system for physical data and simultaneously probe the inhabitants for reaction data. This is the scenario that keeps planetary defense analysts awake at night, not because it implies hostility, but because it implies assessment. And assessment precedes decision-making. Now let's look at the improbability stack with fresh eyes. Every anomaly has a natural explanation. Ecliptic alignment could result from ejection geometry in the source system. Sunward jets could result from rotation. Large size could result from formation in a massive disk. Planetary flybys could be coincidence given the short observational arc. Nickel enrichment could result from metal-rich protoplanetary material. Low water content could result from thermal processing. Extreme negative polarization could result from unusual surface regolith. Arrival direction, alignment with the WOW signal, could be coincidence compounded by confirmation bias. But here's the methodological challenge. If you encountered an object that was artificial, what would it look like? It would not announce itself. It would not violate physics. It would not emit radio signals on command or respond to hails. It would be designed to blend in, to masquerade as natural until it completed its mission. The only signatures would be statistical. An artificial object would have a trajectory optimized for mission objectives, not dictated purely by gravitational scattering. It would have a composition optimized for function, not constrained by protoplanetary chemistry. It would have behavior optimized for data return, not purely reactive to solar heating. In other words, an artificial object would look exactly like a natural object with a statistically improbable combination of features. And that is precisely what we are seeing. This is why the Loeb scale was developed. It's a 0 to 10 ranking system quantifying the likelihood that an object is of artificial origin based on cumulative anomalies, 3i. Atlas currently ranks at 4. That classification translates to unusual, but not conclusive. It is high enough to justify systematic follow-up, but low enough to maintain the default hypothesis of natural origin. A rank of 6 would trigger international coordination protocols. A rank of 8 would trigger intercept mission planning. A rank of 10 would mean unambiguous artificiality. We are not there, but we are no longer at 0. So what happens next? What should we be watching for? This is where the science thriller becomes science fact, because the next 6 months will provide data that could shift the probability distribution dramatically. First, observational reacquisition. 3i Atlas will emerge from solar conjunction in early December 2025. Ground-based telescopes will reacquire it, and the first priority will be confirming its trajectory. If the orbit has changed, if there is any deviation from the gravitational path predicted by pre-perihelion observations, that is a signature of propulsion. Natural comets experience non-gravitational acceleration due to outgassing, but those forces produce predictable, continuous, low-magnitude changes. A discrete delta V impulse, a sudden trajectory shift, would be unambiguous. NASA's Center for Near-Earth Object Studies maintains sub-kilometer precision on orbital predictions. Any deviation larger than the error bars demands explanation. Second, post-perihelion activity changes. Comets brighten as they approach the Sun due to increased sublimation. They dim as they recede. If 3i Atlas brightens or maintains brightness post-perihelion longer than thermal models predict, it suggests an internal energy source. If the coma composition changes, if new chemical species appear, if the nickel emission intensifies or disappears, those are clues to internal processes. Third, secondary object detection. ESA's Jupiter Icy Moons Explorer, known as JUICE, will observe 3i Atlas on November 4th at a range of 64 million kilometers. NASA's Europa Clipper may pass through the Ion tail. NASA's Juno spacecraft will observe at radio, infrared, and ultraviolet wavelengths during a close approach of 54 million kilometers on March 16, 2026. These platforms have the sensitivity to detect objects down to tens of meters at close range. If mini probes were deployed, if the primary object fragmented into multiple components with divergent trajectories, these spacecraft would be positioned to see them. Fourth, Earth closest approach on December 19, 2025, at 269 million kilometers. If 3i Atlas is surveying the solar system and following a pre-programmed mission profile, Earth would be a priority target. A trajectory adjustment to bring it closer to increase resolution to sample the upper atmosphere would occur during the post-perihelion period. We will know by January whether that adjustment happened. Fifth, communication attempts. Multiple radio observatories, including the Green Bank Telescope and the Parkes Observatory, have been allocated observation time to scan 3I Atlas across a wide frequency range. If it is transmitting, even at milliwatt power levels, we would detect it at the distances involved. If it is receiving, attempts will be made to transmit simple mathematical sequences, prime numbers, hydrogen line frequencies, the universal constants of physics. This is not METI, messaging to extraterrestrial intelligence in the broadcast sense. This is pinging a known object to determine if it responds. The distinction matters. Sixth, Project Lyra intercept feasibility. Since Oumuamua, researchers have modeled intercept missions to interstellar objects using existing or near-term technology. For 3I Atlas, a launch window exists in late 2026 using a Jupiter gravity assist and solar Oberth maneuver, with intercept achievable by the mid-2030s. The mission would require nuclear thermal propulsion to achieve the delta-V budget, but the technology exists. The political and financial will does not yet. But if post-perihelion observations increase the Loeb scale ranking, if the object demonstrates unambiguous anomalous behavior, the calculus changes. A mission to 3I Atlas would answer the question definitively. It would also require international coordination on a scale never before attempted outside of wartime. Let's ground this. The overwhelming likelihood remains that 3I Atlas is a comet. A weird comet, yes, but a comet nonetheless. The galaxy is vast and ancient. The diversity of planetary formation environments is staggering. We should expect to find objects that challenge our models. We should expect statistical outliers. The universe is not required to conform to the narrow range of phenomena we've observed in our own solar system over a few centuries of modern astronomy. But science does not progress by assuming the default hypothesis is correct. Science progresses by testing the default hypothesis against alternatives until one framework clearly explains the data better than any other. Right now, we are in the uncomfortable middle ground, where the natural hypothesis fits most of the data, but struggles with the cumulative improbability of the full data set. That is not evidence of artificiality. That is evidence that we need more data.